All right, so here is our next topic, working on stoichiometric conversions. This topic is working with mass-to-mass style conversions. So how does that differ, and how is that similar to what you've already began with? So you still use a balanced chemical equation to develop a mole ratio. So the given and what you were solving for in all of worksheet A were mole units. Now here, typically we work with mass because then we can associate that with the scale and we're able to measure it in a lab. And so from here, we have problems starting out with tin 2 fluoride, SnF2, is often used in toothpaste, and here is our reaction. Tin single replacing in hydrofluoric acid to make tin 2 fluoride and hydrogen gas. So looking at balancing, my tin is balanced, my hydrogen and fluorine are not. A coefficient of 2 is all that's necessary on the reactant side. So for every 1 mole of tin requires 2 moles of fluoric acid, hydrofluoric acid, to make 1 mole of tin 2 fluoride and 1 mole of hydrogen gas. So in this problem, it asks how many grams of tin 2 fluoride are produced from the reaction of 30 grams of HF. So this problem, same idea, again, you need a mole ratio, except we are starting with grams here. So our given is 30.00 grams of HF. We want to get to grams of SnF2. The ratios up here cannot represent grams because we have unique molar masses. They can only represent, in this case, moles. They can sometimes represent liters, but we're going to keep it with moles right now, or atoms or molecules, but we're going to stick with moles. So the very first thing, thinking back to our mole unit, is the only thing we know to get grams to moles is we need the molar mass of this compound. So HF is made out of hydrogen, which is 1, and fluorine, which is, there's 1 of them, with a mass of 19. So the molar mass here is 20 grams per mole. So this, again, is going back to our very last unit. Like I said, this kind of is a snowball effect type unit. And so when we do that, when we set that up, just like with last unit, we need our grams to cancel. So 20 grams is my denominator, and 1 mole is my numerator. So then from there, my grams cancels, and I'm now 2 moles of HF. So now, like topic 1, you now develop a mole ratio to switch the identity that you're talking about. We want to compare HF to SnF2. So my ratio here is, I see that I have 2 moles of HF is to 1 mole of SnF2. So moles cancels out. We're at our moles of HF, I should say. We're now at moles of SnF2. The very last piece is they want grams. So like before, now that we've exchanged from our reactant to the product we're looking at, the tin 2 fluoride, we need to know the molar mass of SnF2. So from there, we have tin and we have fluorine. We have 2 fluorines, and so then that's 19 and 10. Looks like it's 118. My periodic table's too far away. Let me grab mine. There we go. Sorry about that. So 10, yeah, is 118.71. I just wanted to make sure the one on my wall is kind of far away. So then when we go to get a tally there, take 118.71 plus 2 times 19, and so we get 156.71. So again, looking at this, and that's why units are so important, is here we have moles of SnF2. So that means 1 mole is going to go in the denominator, and the mass of 156.71 grams is my numerator. So then when you go to solve, again, I leapfrog it. So I'm going to take, and let me turn my brightness down so it's a little bit easier to see in the video. There we go. So you're going to take 30, divide by 20, divide by 2, times 156.71. 30 technically has 4 sig figs, so this is technically 117.5 grams of SNF2 to correct number of significant figures. So laughing gas, if you've ever been to the dentist, sometimes they give you, it's also nitrous oxide is the more technical term, but is commonly called laughing gas. And it's typically when you decompose ammonium nitrate, we make the nitrous oxide and water. Looking for balancing the nitrogen are balanced because there's 2 between the ammonium and then the nitrate. We have 4 hydrogen and 3 oxygen. So let's take care of the hydrogen. So 2 times 2 will give me 4. That gives me 2 times 1 for my oxygen plus the 1 here. So that balances it out. So it's a 1 to 1 to 2 ratio. So again, the starting point here is our given is 33.0 grams of this N2O. And so from there, what you want to do is convert it to moles first. So again, whenever you start with grams, the very first thing you do is convert it to moles using its molar mass. So N2O, we have nitrogen with 2, oxygen with 1. So the molar mass there, let's see here, looks like 44.02 is what our total is going to come out to. So once you get to that point of it's now in moles, the next step, it follows the same pattern every single time. As soon as you converted it to moles, we can now use the mole ratio. So again, you could start at any starting unit of like liters, grams, or molecules. You would use the coordinating conversion factor, molar mass, Avogadro's constant, or molar volume to convert it to moles. Your next step is always, always, always your mole ratio. So we have N2O using my balanced equation. That is 1 mole of N2O. They want to know how many grams of ammonium nitrate are required. So the ratio there is a 1 to 1 ratio. So the last piece then is you need the molar mass because it wants grams. So 1 mole will go in the denominator. We need the number of grams by calculating its molar mass. So we have nitrogen, there's 2 of them. Hydrogen, there's 4. And oxygen, there's 3. So the molar mass of ammonium nitrate looks like 80.02. So then typing this through the calculator, 33 divided by the molar mass of 44.02. This part, it's a 1 to 1 ratio, so nothing's necessary for the calculator. So then you multiply it by the mass of 80.02. And that looks like 59, and that is a domino effect. So we're going to say 60.0 with sig figs grams of ammonium nitrate. Okay. So then in B, it asks how many grams of water are produced in this reaction. So you can start with either given. You could use the 33 grams of N2O, or you could use the 60 grams of NH4NO3. Either one you can start the reaction with because it's all based on that mole ratio. I'm just going to start with the 33 grams. So to start out, that first part all stays the same. 1 mole of N2O is to 44.02 grams. The molar mass of it has not changed. And I can already start setting up my mole ratio with the denominator because, again, that stuff is all the same because we're talking about the same compound. So that means to get to water, though, it's a 1 to 2 ratio with 2 moles of water being the numerator. We have found the molar mass of water quite a bit, especially with the last unit. So 1 mole is the denominator, and the 18 grams is my numerator there. And that's going to get me to grams of water. So when I type this in, it's 33 divided by that 44.02, just like before. and we get that 0.74. Now we need to times that by 2, times that by 18, and we get an answer of 27.0 grams of H2O. So again, when you look at these 3 examples I just worked through, you have the same thing. You take your given, the pattern is you convert it to moles, and that's with your molar mass. The next thing is your mole ratio, and that's of your given to your unknown. And the last piece is if it's asking for grams, you're going to then convert it to, and I'm going to add this given in grams. So then you're going to solve for your use molar mass of unknown. And that will result in your answer of grams of unknown. So again, you're going to go through that same channel each time to get your units to cancel. And if you have questions on how to do mass-to-mass conversions, please reach out and let me know.